How to make RC car bodies using the Smooth-Sil 940 and 960 liquid silicone rubber and the Freeform Air HT epoxy putty. Now in today's video, we're going to show you a step-by-step procedure that we use to go from an original model to a soft silicone tool that's flexible to finished RC car bodies that are vacuum formed over our soft tool here. Now, our project today does have several goals. We're trying to reproduce as much detail as possible into the vacuum form parts that we're making. We also wanted to show you how to create a flexible tool for vacuum forming so it can be easily removed from any undercuts that the tool itself has. And of course, we wanted to show you how you can easily make many vacuum form pieces of an original, as well as using materials that can withstand the heat from the vacuum forming procedure. We also wanted to show you how to create an original mold or master mold that can be easily used to reproduce new tools or new molds for production settings. Now let's just jump into this project and see how it's done. Vacuum forming is a process where a sheet of plastic is heated to a forming temperature, stretched onto a single surface tool, and forced against the tool by a vacuum. This process can be used to form thermoplastic sheets into permanent objects. Conventional techniques of producing a tool can be costly, time-consuming, and labor-intensive. Using new techniques and materials will save you time, save you money, and save you labor over conventional techniques. I originally created the form or mold the traditional way by casting it solid out of a heat-resistant epoxy. However, what I discovered is that the front and the back end of this mold here or tool create a undercut that creates a locking between the vacuum form piece and the rigid tool. You can see that the vacuum form body here fits so tightly around our model that it was unable to be removed, and when we did remove it, we actually broke it and ripped it apart. Because of that issue, we're going to be creating a softer silicone skin that goes over a rigid shell made of a epoxy putty. This will allow us to peel the silicone skin out of the vacuum form body that we created without destroying it. So potentially what we will have is a hard shell that's made out of Freeform Air HT epoxy putty and a silicone skin that sits over that actually houses the detail of our tool. The model I will be using for this project today is going to be this old RC car body, and I noticed that there are some gaps between the windows and the main body, so I will fill those with some clay. This is Sculptex soft oil-based clay. So any cracks where the silicone that we're going to use to make the mold can seep into and underneath the model are going to be filled with the oil-based clay. Because our model is hollow, I will support it with some foam blocks that we're going to cut. This is regular building foam that you can get at the hardware store. And I'm simply going to quickly glue them together in order to support the overall shape of the car, the model that we're trying to make. The foam is cut with a razor blade to support the shape that we're trying to mimic. The reason why we need extra support underneath the model here is that we're already anticipating we're going to be pouring a large quantity of silicone over the model. And because it's hollow, I'm worried that the weight of the silicone can deform or collapse the model underneath. So that's why we're going to be using the lightweight yet strong foam to prop up the model. Using the Sculptex soft oil-based clay, we're going to build up a bed that the model is going to sit on. This is our working surface, so to say. And I'm simply going to speed through this so you guys can see how I go about claying up these models. And I'm going to flatten out the surfaces as much as possible. And then we're going to start to fill in the areas around the model. You can notice that I raised the model off the working surface, and that the wheel wells and also the underneath of the model is sloped away from the model. Because the vacuum form pieces will be removed up and over the model, we want to make sure that the edges are sloped away from the model, and we'll have an easier demold. Now the mold box can be built around the model itself, and I'm going to simply smooth out some of that Sculptex clay to make this mold as clean as possible. And then again, using the hot melt glue and some melamine boards here, we're going to put this box together. Here I'm going to put a plexiglass window in the front of the mold so that when I'm pouring the material, you guys can actually see into the mold. As mentioned, we're going to be using the Smooth-Sil 940 Platinum Silicone. The reason why I chose to use this material is because of its higher durometer. This is a 40A durometer silicone, and because of its hardness or stiffness, it holds shape much better than a softer silicone would. So the firmer silicone keeps its shape easier, keeps up its weight easier, and won't buckle or deform under its own weight. This in turn will allow me to create a mold skin. That's what we're going to create in this mold. That's going to keep true to its original shape and form. And again, it will not distort. If you take a look at the shore hardness scale that you can find on our website, this would put things more in perspective as what to expect from a certain shore hardness that relates to objects in the real world. As you can see here, the 40A durometer silicone will feel something like a pencil eraser, so quite stiff and easy to hold its shape. Now the Smooth-Sil does have a mix ratio of 100A to 10B. That means we're going to have to use an accurate gram scale to dispense the material. It has a working time or pot life of 30 minutes, while the cure takes 24 hours. One thing to note and understand on the technical bulletin is that the mixed viscosity of the material is quite high. At 35,000 centipoise, or CPS for short, the material is more likely to trap air bubbles because of its thick consistency. Therefore, it is recommended to vacuum degas the material to eliminate any air bubbles that may be trapped from the mixing procedure. Because we are mixing a large quantity for a large mold, I will be using 2-gallon kits of the Smooth-Sil 940. Therefore, I will be mixing the material in a 5-gallon container in order to contain all the material, especially once we expose it to vacuum. Keep in mind, when vacuuming silicones, they will expand twice, if not more, the original amount that you have in the container. So it's really important to accommodate that when mixing large quantities of material to understand how much they will expand and how big of a mixing container you will need for this application. To begin the mixing process, both parts A of the silicone are combined in the 5-gallon mixing container. The reason why I'm not using a gram scale is because I'm dispensing the entire gallon kit into the mixing container, and the material has been already weighed out so that if you use the entire batch, the material will have the correct mixing ratio. And then we're going to add the part B. Now, using a variable speed drill and a turbine mixer, the two components are mixed together by scraping the sides and scraping the bottom off the mixing container. Make sure to bring up any material from the bottom up and mix it as thoroughly as possible. Once the mixing procedure is complete, I'm going to transfer the material into a second clean mixing container. And here you can clearly see that at the bottom of the mixing container, there's still some unmixed material. The colors have not blended well. And I will upgrade to a electrical drill mixer here with more power. and then mix the entire batch one more time, scraping the sides and scraping the bottom off the mixing container. The mixed material can now be exposed to vacuum using a vacuum chamber. And one thing you want to keep in mind when working with materials that you know you have to vacuum is to keep the working time or pot life in mind. Does this material have enough working time for me to mix and vacuum the gas before it starts to set up? The mixed material is now exposed to 29 inches of mercury to vacuum the gas air that has been trapped in the mixing process in the material. And we're going to allow the material a rise and a fall. This is the correct procedure for vacuum degassing. Once you see that rise and fall, you're going to allow the material another 90 seconds to continue to vacuum and pull air out of the mixture before shutting the machine down and releasing the air valve, allowing air to enter the vacuum chamber. The silicone is now poured into the mold box that we prepped earlier, and we're going to pour in one spot, the lowest spot of the mold box, and allow the material to seek its own level. That way it's going to push any kind of air away from the model and make sure that we don't have any air bubbles trapped on the surface. The material is now allowed a full cure for 24 hours. After a full cure, we can go ahead and demold our mold. We can remove the melamine board that we used to make our mold box. And then we're going to slowly remove the model out of the mold itself. You can see that the glass part of the model popped out easily first, and then slowly I'm going to work that model out of the mold. You can see how stiff that rubber mold is because we went with a higher diameter rubber versus a lower diameter, which allows us to keep the model or the mold nice and stiff for future reproductions. The next step here is to cover the inside of the mold, and I'm going to use some regular aluminum foil that you can get at any grocery store. The aluminum foil is basically a barrier layer that will protect the inside of the mold. Using the Sculptex Soft, which is an oil-based clay that I've already rolled out in a 1/2 inch thickness, we can now slice that into strips to create the silicone skin from our mold. Keep in mind that everything that we create out of the Sculptex clay here will eventually become the silicone skin that we're going to use over our tool to pull the vacuum. So I'm just going to fast go through this and show you how I build up that clay inside. Again, trying to keep the same thickness and then smooth out some of those walls of the clay up. And you want to keep in mind that these clay walls that we're building up here cannot cause any interlocking between the clay, so to say, and the plug. So all the walls have to be sloped so that the plug we're creating can come out of our cavity here with no problem, or in the future out of the silicone skin that we're creating. This key here that will be eventually in the silicone will allow the silicone skin to find its original resting place in our rigid tool more easily. And then we can proceed to make the actual plug that's going to be made out of the Freeform Air HT, which is a epoxy putty that has high temperature resistance. So the Freeform Air HT is a lightweight epoxy putty that offers high temperature resistant up to 300 Fahrenheit when cured at room temperature and 400 when cured in a post-curing oven. The pot life or working time of the Freeform Air will depend based on the thickness that you apply the material in. So for example, if you apply the material at a 1.5 inch thickness, the pot life would be about 90 minutes, while the handling time is 3 hours. That means the full cure will be achieved in 16 hours. The Freeform Air HT has a 2A to 1B mix ratio by weight or by volume. Now, this is really important to keep in mind because if you have used the freeform air in the past, you may remember that the mix ratio is different from the freeform air HT. Epoxy putties are very adhesive substances, and a release agent is recommended when applying the material to non-porous surfaces such as resin, metals, glass, etc. You can use sonite wax available from Smooth-On, as well as other designated release agents. The heat resistance of the freeform air HT, with a minimum thickness of 1/2 inch or 1.27 centimeters, will resist temperatures up to 300 Fahrenheit. As mentioned in the technical bulletin, I'm going to be using the sonite wax, and we're simply going to apply it directly to the Sculptex oil-based clay that we put in here. And once you cover the entire surface, we're going to allow the sonite wax to dry for 20 to 30 minutes. I can now proceed to dispense the freeform air HT. Remember, this is 2 parts A to 1 part B by volume. So I can simply start dispensing. To minimize any chance of cross-contamination between the containers, you always want to make sure to change the gloves between the dispensing of the part A and the part B. The freeform air HT is a lightweight epoxy putty. To mix the material, I'm simply going to start by folding it on to itself, so just like bread. If you're making dough for bread, you just continue to fold it onto itself, and you're going to continue to mix it that way until you get a unified color that doesn't show any streaking of the individual components. Keep in mind that epoxies are exothermic materials, and keeping a lot of material in mass will expedite the cure of the product, while flattening out the material into a thin pancake will prolong the working time of the material. So here you can see once the material is mixed, we can apply it. I'm keeping the thickness of the freeform air as even as possible through the entire buildup. We want to keep in mind that thickness reference guide that's in the technical bulletin that we looked at earlier, and what the working time with the material will be based on the material thickness. I aimed for about 1 inch thickness on the model here that we're creating. Once the entire model is built up with the desired thickness, you can use a little bit of water from a spritzer bottle to smooth out the surface of the freeform air. Do not over apply the water so that it sits and pools inside your model. You want to have just enough to get a wet, slippery surface on your hands so that you can work the texture of the freeform air to a smoother and slicker surface. The freeform air HT is now allowed a full cure of 16 hours. After full cure, we can go ahead and demold the entire buildup. We're going to remove the clay and the freeform air shell that we built inside a mold. Once the shell is removed, the freeform air edges are cleaned up of any sharp corners. And then I'm going to drill some venting holes into that channel key that we created in this shell. This is where the silicone will shoot out as we fill the cavity between the mold itself and this freeform air shell. This will make sure that that key is solidly filled with rubber and does not trap any air bubbles in that area. Now, before we attach this plug, I'm going to use some Ease Release 205. This is a release agent for silicone to silicone application. I'm using the liquid version because I have more control over the application. I can see exactly where I'm applying the release agent. Keep in mind that you don't want to over apply the release agent and have it pool at the bottom of your mold. I'm going to brush in a layer off the Ease Release 205, and then we're going to allow this to fully dry for 10 minutes. The wood strips are adhered using some hot melt glue to the freeform air HT shell that we created. And then using a variable speed drill, With a drill bit, I'm going to mark the areas where we're going to drill all the way through the wood slats. I'm not going to go all the way through into the silicone here. And then once we remove the shell from the silicone mold, and we're going to drill through the wood completely. And then we're going to use those holes that we drilled through to secure the shell into the silicone mold. And then use some wood screws to hold this in place. Now you have to be very exact when placing the shell that we created here now into the mold and securing it. You want to have the same distance all around the shell so that you don't create a silicone skin that's thicker on one side and thinner on the other. So here we have our setup that's ready now to be poured with some silicone. The reason why we secured the freeform air HT shell in the silicone this way is so that it won't float up as we pour silicone in between the mold and the freeform air HT shell that we created. The silicone skin that we're creating on this plug is going to be made out of the Smooth-Sil 960. The Smooth-Sil 960 has a mix ratio of 108 to 10B by weight, so we do have to use an accurate gram scale. The working time or pot life of the material is 45 minutes, while a full cure takes 16 hours. Really important to keep in mind that this material has extremely low shrinkage, as well as a high heat deflection of 450 Fahrenheit, which will be very useful because we will be exposing this to direct heating elements. While silicones don't stick to many substrates, it is important to apply a release agent when using silicone-to-silicone applications because they will adhere to the same kind of silicone that they're made out of. So East Release 205 was used for the release agent application. Because the Smooth-Sil 960 has a high viscosity of 30,000 CPS, we will use the silicone thinner to bring that viscosity down and help the material flow into the cavity that we created. Furthermore, by using the silicone thinner, the silicone will de-air faster when vacuum degassed. The mixed rubber will flow better into the mold itself, the cavity that we created, while the silicone thinner will ultimately lower the shore hardness or the durometer of the silicone. It'll be very small proportion because it is a 60A durometer, so we will not see a huge impact on the durometer. Furthermore, the pot life of the silicone is increased by adding the silicone thinner and will depend on the quantity of the silicone thinner that you're adding. The disadvantage of using silicone thinner is that the ultimate tear strength is reduced in proportion to the silicone thinner amount that is used. This will not be a problem for our project here because, as you will see, the silicone skin that we're creating will be still very bendable and stretchable for our application. As mentioned, the percentage of the silicone thinner is added to the total weight of the Part A and the Part B of the rubber system. It is not recommended to exceed 10% by weight of the total system combined. Make sure that you follow the technical bulletin for the silicone thinner down to its detail. The Part A is first dispensed, and then the silicone thinner is added to the Part A and premixed thoroughly before adding the Part B. Of course, make sure to use an accurate gram scale when dispensing the Smooth-Sil 960 as well as the silicone thinner additive. Make sure to premix the silicone thinner thoroughly into the Part A by scraping the sides and scraping the bottom just like you would do if mixing the A and B together. Once the silicone thinner is combined with the Part A, we can go ahead and dispense the correct amount of the Part B of the Smooth-Sil 960. Once the Part B is dispensed, we can go ahead and mix the components thoroughly together by scraping the sides and scraping the bottom of the container. And then I'm going to transfer the mixture into a second clean mixing container. This is a double mix technique. So we mix in one container, transfer into a second one. Now everything that was at the bottom of the container ends at the top, and we mix it one more time by scraping the sides and scraping the bottom. The silicone should have a uniform color, and no streaking should be visible of the individual components. The material is now placed into a vacuum chamber and exposed to 29 inches of mercury to vacuum degas any air bubbles that were introduced into the material from the mixing procedure. We're going to allow the material a full rise, and then you can see here, I'm going to break that and allow it to fall, and it's going to continue to bubble up. And that is the action of actually removing the air out of the mixture. And once you see that rise and fall, we're going to continue to vacuum for another 90 seconds before removing the silicone from the vacuum chamber. The Smooth-Sil now can be poured into the cavity that we created between the silicone mold and the freeform air HT plug. And because we added the silicone thinner, the material flows quite nicely. And I'm going to plug those air vent. When I see that the silicone is rising out of them, I use a little bit of the Sculptex soft clay to plug those up. Again, once I see that the silicone is coming out. The rest of the silicone is now poured into the cavity. The material is now allowed a full cure of 16 hours before proceeding onto the demolding. After a full cure, we can go ahead and demold the silicone that we poured. We're going to start by removing the screws and those wood slats that we glued onto the freeform air tool that we made, the shell. And then we can simply demold the shell first, the freeform air, and then the silicone is peeled out as well. And you can see how flexible that is. Even a 60 durometer can be flexible enough to be peeled out. Here's our finished silicone sleeve that will be used for the vacuum forming application. And again, here you can see how bendable and stretchy that material is. To create the vacuum on the model itself, we still do need to punch air holes into the model itself. So I'm going to be using these brass tubes that I have. These are telescoping tubes in many different sizes. You can buy them in different shapes as well. Hardware stores will have them. For this model size, I ended up using about a millimeter to 2 millimeters punch hole that gave me enough air circulation through the entire buildup in order to get good quality pulls off our model here. These air holes are punched in very specific places where we want the detail of our model to show up in the vacuum forming that we're going to be doing. So any detail, any corners here are going to be punched with a hole, including the lights and any kind of recesses. So you can see here in the lights and the corners, I have punched holes all around. Now with a sharp tool, I'm going to mark the form underneath, the freeform air shell that we created. I'm going to punch these holes basically to mark where we need to drill holes into the freeform air. Remember, we need a complete pass from the silicone through the shell here to the vacuum that is being created in the machine that we're going to be using for the vacuum forming. So I'm going to go around and all those markings that we created, and I'm just going to check a couple of times, make sure that we have all of the corners covered. And this is what the freeform air shell now looks like underneath. It has all these holes that we created for the vacuum itself. If you find that a specific area is just not getting enough detail, you can always add some more vent holes down the line once you start pulling the first vacuum form examples off the tool you created. The tool is now placed into the vacuum forming machine, starting with the inner shell that we created and then the silicone skin. We can then lower the tool and a plastic sheet is inserted that we're going to form over the tool. It's trapped in place and the heating element is slid over the plastic sheet to warm up. Once the sheet is heated up, the heating elements are slid back and the tool itself is raised into the plastic sheet and exposed to vacuum. The freshly vacuum formed material is allowed a moment to cool down before being removed from the vacuum form machine. And here you can see that by first removing the core that's rigid, we're now able to remove the silicone skin out of our vacuum formed object much easier without destroying the vacuum form object that we just created. The model is now trimmed out following the seam lines on the model. The edges are sanded using a sanding disc to clean up any sharp corners and tighten our cut closer to the model and line it up to the seam lines that are created in these vacuum formed pieces. The vacuum formed body is now fitted over the chassis of the RC car to make the alignments for the body posts that will be carrying the shell on the chassis. The body of the model is washed, masked up, and then painted on the inside of the vacuum formed model. So we're going to paint the inside with the masking for the windows in place. And we're going to apply several layers of the paint. So make sure you don't spray paint all at once, but rather do several layers of thin application, allowing each layer in between to dry. There are many different paint types that are available for this application, and of course many different designs that you can make. I'm keeping it here very simple, just masking off the windows, and the rest of the body gets painted in one color. I use the Tamiya color for polycarbonate spray paint for this application. Again, make sure to use the appropriate paint when painting this type of plastic for RC car bodies. Once the paint is dry, the RC car body can now be mounted to any type of chassis of your liking. I'm putting the RC car body that we created over a dune buggy chassis so that we can take our model out and ride it in the dirt and rocks. And here you can see the end result of our project, the car body mounted to the chassis and ready for a test drive. We want to give our special thanks to Formac, perfectly formed vacuum machines that made this video possible, and let you guys know that we use the vacuum form model 508 DT to vacuum form the RC car bodies that we used here. Now, if you got inspired by this project and you'd like to give your own projects a go and need some material, you can visit any one of our distributors around the world. So, and there you have it, a step-by-step procedure that I use to create this vacuum form tool that deals with difficult undercuts on the original model. Now, let's take a look at our project goals. We were able to reproduce most of the detail in the vacuum form pieces, as well as create a flexible tool that is easier to remove from the undercuts in those vacuum form parts. Now, we showed you how to easily make many vacuum form pieces from the tool, as well as how to use the correct materials that will withstand the heat from the vacuum forming procedure repetitively. Finally, we showed you how to make a mold that you can use to easily reproduce new tools for a production setting. Now, if you have an idea about what we should do next, please let us know down in the comments below. If you like this video, hit the thumbs up button. To keep up with our latest mold making, casting, and other videos, remember to subscribe.